I will not waste time and introduce our final speaker for this session. It's Mr. Taurai Hungwe. He's employed as a computer science and information technology lecturer at Sefako Mahato Health Sciences University with more than 20 years of experience, and he holds the doctoral degree in science, master's degree in information technology, Master of Education in Educational Technology, Bachelor of Science in Honors in Computer Science with Education, Certificate in Education, Higher National Diploma in Computer Studies and Diploma in Networking, PC Maintenance Engineering. He has a combined publication of 24 articles, papers, conference proceedings, etc. We are pleased to welcome you, sir, to give your presentation to us. Over to you.
Thank you for the introduction. I'm going to look at MQFIP, standing for MySQL Forensic Investigation Process. Just to go through the background and motivation of this research, you'll know that most of our lives, most of our information, all the data which we have generated is stored in our databases. So it becomes that space where most of the people will be looking at and would want to either do other things, nefarious things, criminal activities, and also there could be possible human errors, which we can, through either the hardware failure, software failure, and all the other things. So with all those things, and when we think of how much data which we are actually generating each and every minute, each and every second, then there is need for us to look at database forensic investigation. Briefly, database forensic investigation is part of digital forensics. And all what we need to do is, in digital forensic investigation, we want to collect the digital evidence. So that digital evidence remains behind whenever we collect our data, whenever there is a mishap in the database. So to do this, in the main or the focus of digital forensic investigation, we'll be looking at identifying the data, collecting it, preserving it, analyzing it, and presenting that data. And with all those processes, one of the aims would be to be able to preserve or to present that data, which can be used for litigation purposes. And the other aspects which we look at is actually we need to also recover the data which would have been lost when we have these mishaps of broken down hardware or software. So there are quite a number of researches which have been done. One was done in PostgreSQL, and then we also have Microsoft SQL, when they looked at the engine-based recovery method. Then we also have other researches on categorization and organization of data forensic investigation. With all these aspects, why then look at MySQL forensic investigation process? For each and every instance of the database, the investigation is different. And hence, that's why I had to look at MySQL forensic investigation process. And also the other aspects why MySQL forensic investigation process is one of the widely used database in the world. And also it presents the coding of that database is very minimum. So in terms of storage, in terms of the use on mobile devices, it will actually suffice. So the aim was to study MySQL database. And to do this, I looked at a scenario-based investigation. In that scenario-based investigation, we're looking at saying, at which level would that database be affected? And with all those aspects, then we had to look at how can we reconstruct and restore the database. So for the specific objectives, we looked at 4 abstract layers. And these 4 abstract layers are defined in the ANSI SPARC model. And we'll look at those levels in this next slide. So when we look at the 4-level database system architecture, we're looking at mainly 2 sections, where we are looking at the data model and the application layers. Our data model layer, that's where we have our metadata and all the other aspects of the database. The data dictionary, that's where we have all the descriptors of our database, our schemas, and all those other things. And the rest, I think, they could be self-explanatory up to the application data layer. So when we map that 4-layer database to our MySQL database, you will find that the MySQL code will actually map with the data model layer. And for the data dictionary will find it in the IB data file. Then when we look at our application schema layers, these are stored in the .frm files. Then the last layer, that's where we have our actual data. Just to have a look at how is this data stored within the database. This is an example of the IB data file. And within that IB data file, I used the hex editor. The hex editor to be able to look at the hexadecimal representation of information. If you look at the other side there, on the left side, you'll find it actually shows the different objects within the database, which are easily readable from that end. Similarly, with the .frm files, you'll find we have more or less the same representation of data. So as we have said, we're looking at the 4 layers, go through the inspection of MySQL database. Then before we can do anything, we start by replicating the data, so that when we make changes, then we want to go back to and compare with the replicated data database. And with that, we check if we are able to reconstruct the database. So we had a number of experiments at each and every layer. At the data model layer, we had a few experiments there, and we simulated unauthorized changes to the database management system. And with the type of databases which we had created our HR database. We also created the student database. Then we would go on and make changes to those different layers. And we got a few results and conclusions to see what happens when we remove or we make changes to the database. So in a number of cases, we're actually looking at, again, if you look at the previous slide, to say we can be able to locate the point where we want to make a change. And that point will actually correspond to either student or the enrolls table. So when we make some changes to that structure, and we're also saying in most cases, when people make changes, they would want to make changes at that level, which is more difficult to be detected. So also the other aspects which we did, we looked at the data dictionary layer, we went through the data dictionary layer and made changes. The application schema, we used the .frm files, and the conclusions and the results are also projected on the other side. Then, if we go back to the applicability of the standards of investigation process, plus and activities, the ISO IEC 27043 standard looks at the database forensic investigation. When we look at the concurrent process, we have concurrent processes on one side. We have the other processes which flow from readiness process until the last end of the investigative process. So with that, we went further to say, where does that MySQL forensic investigation fits? And you'll find with that blue line there, that's where we thought would make changes to the harmonized digital forensic investigation processes. Just to expand on that, at that point where we have looked at in the investigative processes, then would plug in the MySQL forensic investigation process, where we will look at an algorithm which will go through the potential digital evidence acquisition and go through all the processes, checking each and every layer, and until we are able to get to the point of reporting the incidents. In conclusion, we carried out all those experiments. Then maybe one aspect which needs further investigation would be when we made some changes to the .frm files. And when you check on the results, you will find it will show the exact information as if nothing would have been changed to the .frm files. So we tried to look at the explanations. You'll find a lot of information for the .frm file also resides within the IB data file. The IB data file which resides, which is mapped to the second layer, the data dictionary. So in other words, in such scenarios, you will find MySQL database or database management system will be able to read some of that information and shows the correct information from that altered database. I thank you.
Thank you so much, Taurai. for sharing with us forensic investigation process, database investigation, forensic investigation. We really appreciate the effort. This is just a token of appreciation from us for making time to present to us. Thank you so much. Now, colleagues, we've come to an end of our first session for the day. I can now open to you to pose a question or two because of time, so that we can have a look at the next session. I've got a hand up there. If I can have a mic. Someone can assist me with the mic. I noticed that our first speaker, Polani, just here on the left. I noticed that our first speaker, Dr. Motsefa, is not in the room. But if you pose the question, we'll take note of it and let him maybe try and see how to address your question. You can go ahead, sir.
Yes, so the question for the first speaker is in terms of the data usage of the system in the field for recording the livestock parameters. How intensive is it in terms of megabits per second or so forth? The data usage. Is there network coverage required and so forth? And another question for the second speaker is in terms of if a bad actor had gained access to the database and just simply copied the information and not changed anything, but actually stolen your information and your within the database, is there a way for you to know that that's been happened and what steps would you take?
Yeah.
I was the second speaker, so I didn't hear your question. I thought you were addressing this first speaker. Would you please repeat that?
Okay, yes. Thanks for your talk. It was very, very interesting. The question is in terms of the bandwidth and of the devices and the images needed to be captured. How much bandwidth is used in the field? Do you need like 5G connectivity? Can it work off a simple 2G network?
Can you guys hear me that side?
Yeah. Oh yeah, Simon, go ahead.
Yeah. Okay. I'll help out a bit there. So the data capture tool is set up so that it can do data capture without connectivity. So all content is in the phone itself. Obviously, if we want to process the images to improve things afterwards, we need to transfer those still images through, and it's not absolutely essential for us to get to a graded price to have done that data transfer. So, but obviously, Kasim can't do his work without having the images to process afterwards. So. So the answer is it will function in the field without connectivity, but in order for us to improve the system and also generate automated algorithms for the future, where we're able to just sort of do grading on the images themselves, that won't function without connectivity. And I think in terms of the bandwidth required, We've not really looked at the specific resolutions. You imagine you've got 2 megapixel cameras as the sort of base entry level, going up to 8 or 10. So you get a sense if we're transferring 5 images, approximately the bandwidth for an individual grading that we would need then. Kasim, anything you want to add to that?
No, that's absolutely fine, Simon. And I think that answers your question, does it? Yeah. Basically, we rely on mobile coverage. So you have a phone, so it's, you don't necessarily have to have a connectivity straight away because the app resides on the phone.
Yeah, we've set it as well, so you could do a bulk transfer if you got Wi-Fi coverage. If you wanted to not use your network bandwidth, but wait till you had some Wi-Fi coverage. And sometimes this is going to be managed by an extension worker versus a farmer themselves. And over time, we completely expect the cost of bandwidth to come down, the connectivity to increase. So more and more people can do live image exchange, but it's not necessary. And I think I have discussed with Kasim the likelihood of being able to do some processing in the phone. I think the answer is not yet, but maybe in future.
Thank you. Thank you so much, Simon and Kasim, on answering those questions. I'm wondering if there's any last question from the floor. Or...
Good morning. Okay, so I just want to know how much of domain knowledge did you use or was required in just selecting the features to use to build the model?
Or the
Sorry, I
domain
couldn't
knowledge.
hear the question if that was
No,
directed to
the
me.
question was how much domain knowledge is required for us to be able to select the features for modeling. I mean, the question is, it depends. If you're talking about feed, you're talking about, Simon showed different species of goats, some of which are for meat, some of which are for milk, some of which are for meat and milk, and so on. All those are different types of data. What sort of feed animals get? This information may come from the farmer themselves, from the people with specialty knowledge in animal husbandry. What sort of conditions, in particular color of the dung will signify what sort of diseases or conditions. Again, this information comes from the vet. It's not, it doesn't come from a data scientist. So it's a multidisciplinary approach. We get feedback from people, stakeholders within within the area.
So how did you deal with the dimensionality?
Sorry?
How did you deal with reducing the number of features that you have if there's
No, at the moment there's no model. We don't have inputs and outputs for that, so that we're not saying that these are the features, but we showed you how many features we can extract. We can extract features based on the species. We can extract features based on the condition of the animals. So there's no design matrix yet. We didn't show any design matrix for input and output. So we haven't selected any features yet.
Yeah, can I just expand on some of this? I think I've heard a couple of those questions. So let me address the first one. In terms of domain knowledge, I'd say 90% of our effort is on the science side of the research, to understand the grading, to talk to vets, to try and understand what are the important characteristics either for the meat sector. So the fat and meat study we showed earlier on, I think Kasim ran through that. Or when you're looking at the breeding characteristics, there are some very specific things you look at. The health perspective is saying, is this animal fit for sale? And sometimes it may be giving you an indication of some quality parameters as well.
Thanks, Simon. I think Kasim is here. He will engage with the person that asked the question because of time. I really appreciate the effort that you guys put and also presenting and answering all the questions. Thank you so much to all our presenters and all the participants. We really appreciate your efforts. Thank you so much.